Hey everybody, it's Mr. Carr again. Today we're going to be finishing up Unit 5 with 5D, applying systems of equations. So we've talked about all the different methods of solving systems of equations. Today you're going to be putting them all to word problems. Okay, how do they apply to some real life applications here? At the school pool party, Mr. Lewis bought one adult ticket and two child tickets for $10. So one adult ticket, two child tickets, $10. Mrs. Vroom bought two adult tickets and three child tickets for $17. Write the system that represents the situation and solve. I'm not a huge fan of this question because we don't know the question right now. When it just says write the system that represents it and solve, what are we solving? I don't know. So let's jump down here to part C real fast. Solve for how many adult tickets, how many children tickets were sold. This helps me do part A. Define my variables. I need a variable for adult tickets and a variable for child tickets. Let's go A and C. So A is number of adult tickets. C is the number of child tickets. So now when I read back and I think about that, the number of tickets in each cases, I should be able to write a system now. So that system is going to have two equations with two variables. Mr. Lewis bought one adult ticket. So one adult ticket. So how many adult tickets? All right. That's a little bit frustrating with that one. This is a little bit off because the question does not match up to the information. Okay. We know how many tickets that Mr. Lewis bought and Mrs. Vroom bought. We don't know the price. Solve for the price of adult tickets and the price of child tickets. All right, I'm still going to stick with A and C, but now it's going to be the price of each case. Fine. All right. So Mr. Lewis bought one adult ticket. So whatever the price is, we don't know exactly. We can represent it with 1 times A. That's how many adult tickets that Mr. Lewis bought. So we know that whatever it is $5 for that ticket. 1 times 5 is 5. That's how much he spent on just the adult tickets. We're going to add 2 times the child tickets. Maybe those are $3 a piece. So 2 times 3 gives you 6. That's how much he'd be spending. We do know that the overall price for Mr. Lewis was $10. Okay. Mrs. Vroom did 2 adult tickets and 3 child tickets and spent $17. There's my system. So from here, the goal is, how should I solve it? Should I do substitution or should I do elimination? It's up to you. I think substitution is pretty easy because I could just take this and solve for A. So I subtract 2C over. Then I have A equal to something and I can substitute here. It's also easy with these two, the 1A and 2A, pretty easy numbers to work with. I could take this and multiply everything by a -2 here. If I do that, then I'm going to have -2A minus 4C equal to a -20. 2A plus 3C equal to 17. So now these cancel out. -1C equals to a -3. Divide everything by a -1. C gets 3. Hey, I guess $3 earlier. Look at me go. Okay, from there I can get the adult prices by just plugging it back into one of the equations. So let's go with the first one. 1A plus 2 times 3 equals 10. So 1A plus 6 equals 10. Subtract that over, and I was so close with the adult ticket. It is $4 and not $3. So in context, we have $3 for child tickets, $4 for adult tickets. How much would it cost to buy 5 child tickets and 10 adult tickets? So 5 child tickets, we're going to do 5 times 3 is going to give me $15. For 10 adult tickets, we do 10 times 4 is $40. Okay, so the price for 5 child tickets is $15. And the price for 10 adult tickets, Forgetting how to spell. There we go. Adult tickets is $40. All right. A lot of my other examples just work the same way. We're going to go through the same kind of process. We're going to define the variables. We're going to write two equations that model the scenario. Then we're going to solve it, and then we're going to answer the question. So in this case, we got more question here that has a little bit extra to it, but bottom line is we're trying to answer whatever question they want us to find. All right, example 2. John and Ariana bought school supplies. John spent $10.65 on 4 notebooks and 5 pens. Ariana spent $7.50 on 3 notebooks and 3 pens. What was the cost of 1 notebook and 1 pen? 1 notebook, 1 pen. What is the cost? That's going to help me define my variables. Look to the question. Remember, variables need to answer the question. Cost of each, so that's what I'm going to say. And we'll do N and P, I guess. N is the price of a notebook. P is going to be the price of a pen. So write the system of equations. John spent $10.65 on 4 notebooks, so 4 times N, 5 times P for pens, spent $10.65. Ariana did 3 notebooks and 3 pens for $7.50. There's my system. Solve for how much a notebook and how much a pen cost. So I look at this scenario. I'm going to get rid of N just because they're smaller numbers. I'm going to multiply this by 3, this by a -4. So I have 3 times 4 is going to give me 12N. 3 times 5 is 15P. And that's equal to 3 times 1065. 3 times 1065 is going to be 3195. On the second equation, I got -4 times 3N is going to give me a -12N. -4 times 3 is a -12P. And then -4 times 750 is going to give me a -30. Oh. Okay. All right. So from there, go ahead and combine so I can get rid of my N's. 15 minus 12 is going to give me 3P. This is going to be $1.95 that's left. These are some pretty inexpensive pens. Okay. So that gives me pen cost is 65 cents. So from there, I'm going to go back to one of the equations. So I'll do the second equation. So I'll do 3P plus, 3N plus 3 times 0.65 equals $7.50. Okay, so let's back up to $3.95. So I can subtract that over. Oops. Subtract that over, and I get $5.55. Divide that by 3. And I get $1.85. Okay. So answer the question. 1 notebook costs $1.85. And 1 pen costs 65 cents. Okay, one more example, and that's it for today. The cost to rent a video game from Action Videos. Here's an old-timey problem at this point. The cost to rent a video game from Action Video is $2 plus 50 cents per day. The cost to rent a video game at TV Rentals is $1 plus 75 cents per day. After how many days will it cost of renting a video game? Will the cost be the same for both stores? This one's a little bit tricky, but what we're comparing is cost of renting a video game and days. So that's what we're showing here. So I'm going to do C for cost, D for days. Okay, it's a little bit trickier here, but think of this instead of trying to think of it as like the ones we've done, which is 2x plus 3y equals 7. Okay, we're not going to get that here because what we're getting is, if I think about the cost, we got 50 cents per day, 75 cents per day. Those are rates. Those are slopes there. So I'm actually going to do this as basically a slope-intercept form, y equals mx plus b. But in this scenario, the cost is equal to m times d plus the y-intercept. Remember what these mean. This is my rate of change. This is my starting value. So if I look at the first case at action video, the starting value is $2. The rate is 50 cents per day. So the cost there is equal to $2 plus 50 cents per day. All right. TV rentals is $1. Okay. The cost we're looking at here is $1 to start and then 75 cents per day. Oh, hold on. Just saw that freeze up. All the videos were fine and all of a sudden now. So a quick recap. Slope is a rate, some kind of rate of change. So we're looking at like the 50 cents per day, 75 cents per day. The B value is my starting value. So in this case, it'll be the $2 and the $1. So that's what we're modeling down here. So I kind of switched the order, but $2 per day plus 50 cents $2 to start plus 50 cents per day, $1 to start plus 75 cents per day. All right. From here, we're going to want to do this. We're going to solve for this. How many days will it cost will be the same for both stores? So one thing I didn't really talk about is this. In these kind of modeling scenarios or these real life, we talk about the same. Well, that means it's, again, if I'm graphing these are when two lines cross. That's the point that we're trying to find, that intersection point. So that's why solving with systems works here. We're finding that intersection point through algebra instead of graphing. That's all. So I'm going to rearrange both equations. I'm going to subtract the 0.50d, and that's equal to 2. And I'll subtract 0.75d. That equals 1. From there, I'm going to make everything here the opposite signs. So we're multiplying by -1. So c minus 0.50d equals 2. Negative c plus 0.75d equals a -1. Okay, now, come on. Zoom is being a little tricky for me right now. Okay. So now I've multiplied everything in that second equation by -1. We can cancel out the c values there. I have -0.5 plus a positive 0.75 is going to give me a positive 0.25d. 2 minus 1 is 1. From here, I divide both sides by 0.25. And d comes out as 4. Well, it says then find the cost. So I actually answered the first question. After 4 days, they who is it? The rental stores, whatever, they have the same cost. Okay, so I answered that part. 4 days is when they're going to equal the same amount. But let's find out what that amount is. So I'll just pick one of the equations. So I'll do the first one. So c minus, well, actually, no, I'll go way back to the original equation then. C equals 2 plus 0.50 times 4. So C is equal to 2 plus, that's going to give me 2. So 4. So I got 4 and 4. That works out. So after 4 days, they have the same cost of $4. Okay, just make sure you understand that in this case, C was cost and D was the days. All right, that is it for today. So we did modeling in a couple of ways. We did these, what's called standard form. And that's when I'm just kind of listing number times a variable plus number times a variable equals some other number. But I can also model using slope-intercept form. It just depends on what you're given. So make sure you are paying close attention to how you're reading it, but always pick your variables to answer the question. How many days will the cost be the same? Days and cost is what you're comparing. So that's why my variables are days and cost here. Okay. That's it. All right. Take care, everybody. Have a good one. Oh, it's still